Measurement quality.
A good measurement gives an accurate counter or indicator of the concept that we want to measure. It must also be easy and efficient.
A precise measure indicates fineness or distinction between the attributes of the variable. Although a precise measure is superior to an imprecise measure, but precision is neither always necessary nor desirable.
It is important to note that precision does not mean accuracy. An accurate measure indicates how close the measure is to the real thing or value.
Measurements are subject to random and systematic biases or errors. Hence in research one cannot get 100% accuracy.
The test of reliability and validity of the measurement becomes important.
Reliability, validity, and practicality.
Three major criteria are often used to determine the quality of a measurement tool: reliability, validity, and practicality.
Reliability and validity are associated with how concretely connected the measures are to the constructs, because perfect reliability and validity are impossible to achieve.
It is important to establish the truthfulness, the credibility or the believability of findings, with no random or systematic errors.
Thus, reliability and validity are considered as the scientific criteria of the measurement.
Reliability is related to the consistency of the measurement, which means the recurrences are measured with an identical method or under very similar conditions.
If a particular technique is applied repeatedly to the same object and yields the same result each time, then this indicates consistency.
The criteria take into account the degree to which the measurement is free of random error. Reliability can be assessed by posing the following questions. Will the measures give the same results on other occasions? Will similar observations be reached by other observers?
Is there transparency in how sense was made from the raw data?
Validity is concerned with truthfulness, a match between a construct, or the way the idea is packaged in a conceptual definition and measures.
It reflects how well an idea about reality fits with actual reality, the extent to which the empirical measurement adequately reflects the real meaning of the concept.
In other words, it measures what it is supposed to reflect. Major threats to validity include
history.
If certain events or factors that have impact on the relationships occur unexpectedly while the study is being conducted, and this history of events confounds the cause-effect relationship between the variables, then the validity of the result may be affected.
Maturation effects.
The time passage of the relationship can influence the cause and effect among variables and cannot be controlled.
The maturation effects are a function of processes operating within the respondents as a result of the time passage.
Examples of maturation processes include growing older, getting tired, getting bored, and feeling hungry.
Testing effects.
A pre-test given to the subjects in order to improve the instrument used may actually have effects on the actual test or post-test. The very fact that the respondents were exposed to the pre-test might influence their responses.
Instrumentation effects.
The effects on validity may occur because of changes in the measuring instrument between pre-test and post-test.
Relationship between reliability and validity are shown using this example.
Example.
You use a bathroom scale to measure your weight. If the scale measures your weight correctly, then the scale as a measuring tool is both reliable and valid.
If the scale is tampered and consistently gives an overweight of 6 kilograms every time it is used, It is reliable but not valid.
If the scale gives an erratic weight reading from time to time, it is neither reliable nor valid.
Practicality
is correlated with the operational requirement of the measurement process. The criterion of practicality involves the aspects of economy, convenience and interpretability.
To achieve a high degree of reliability and validity, one may require high expenditure that may be beyond the budget for research. Thus there has to be some form of trade-off between the ideal measures and the budget.
Data collection techniques are always dictated by budget constraints and other economic factors.
The measuring device should also be easy to administer. The design of the instrument used should allow easy comprehension and have complete and clear instructions.
If the instrument is to be administered by people other than the designer, then it must also be easy to interpret.
Sources of measurement errors.
In an ideal situation, a study design should be able to control the precision and ambiguity of the measurement.
However, an ideal situation is impossible. Therefore, the next best thing to do is to go for the reduction of errors.
The researcher should be aware of the sources of potential errors such as systematic and random errors.
Respondent as an error source.
These are errors resulting from the differences in the responses due to the nature of the individual respondents.
Some responses related to the characteristics of the respondent may be anticipated and may be quite stable, but other effects of the characteristics may be less obvious.
An individual who has had a traumatic experience may have a different outlook of a certain situation.
The respondent may be reluctant to state his views or feelings, or may not have much knowledge of the situation and he may be giving guesses of his response.
Other factors that may affect the respondents like fatigue, boredom, anxiety, impatience and variations in moods may also affect the responses.
Situational factors.
Any condition that may place strains on the interview can have serious effects on the interview respondent rapport.
If the interview is carried out in the company of other people, friends, relatives and children, the responses can be distorted by others joining in, distractions or by others just merely being there.
Some may feel they are being intruded upon and thus may not willingly give their responses.
Measurer as an error source.
If the interviewer or enumerator changes the wordings, paraphrases or reorders the sequences of the questions, these could lead to errors.
The first impression of the interviewer to the respondent can introduce bias. The voice tone of the interviewer can encourage or discourage certain replies.
The failure of the recorder to record the full responses may affect the findings. When data is not entered correctly for analysis or a faulty statistical analysis is used by the researcher, it may introduce further bias.
Instrument as an error source.
If the instrument used is defective, two major sources of distortions can occur.
The first, which uses complex wordings, syntax and jargon beyond the comprehension of the respondents, can lead to confusion and ambiguity.
Questions that violate the criteria of a good survey design will cause respondents to give biased answers.
Leading questions, ambiguous meanings and multiple questions are some examples of sources of errors in the instruments.
The second source of errors related to the instrument is the incomplete inclusion of the content items.
It is impossible to include all potentially important issues related to a problem. Although the instrument may take into account the majority of the issues, there could be some that are left out on purpose.
Self-check.
What are the four major sources of measurement errors? Give an example of how each source can affect the measurement results in a face-to-face interview.
2. Measurement should meet the criteria of practicality, which is typically defined as 3. A researcher must decide in the process of operationalization. Summary.
In scientific research, the measurement's use must be precise and controlled.
In the process of measurement, what is actually done is measuring the properties of the object rather than the objects themselves.
To be exact, what are measured are the indicants of the properties. Measurements usually use some type of scale to classify or quantify the data collected.
4 types of scales are used in increasing order of power: nominal, ordinal, interval and ratio.
The nominal scale highlights the differences by classifying objects or persons into groups, and provides the least amount of information on the variable.
The ordinal scale provides some additional information by rank ordering the categories of the nominal scale.
The interval scale also provides users with information on the magnitude of the differences in the variable. The ratio scale indicates the magnitude and proportion of the differences.
The data becomes more precise when we move from the nominal to the ratio scale and allow the use of more powerful statistical tests. Sound measurement must meet the criteria of validity, reliability and practicality.
Validity reveals the degree to which an instrument measures what it is supposed to measure. A measure is reliable if it provides consistent results each time it is used.
Reliability is a partial contributor to validity, but a measurement tool may be reliable without being valid.
A measure meets the criteria of practicality if it is economical, convenient and interpretable.